My name is Lawrence Datnoff, and I work for the Louisiana State University and Louisiana State Agricultural Center. I'm a plant pathologist. I'm professor and department head for plant pathology and crop physiology. We have about 15 scientists and 31 students pursuing masters and PhDs. And the research is pretty all-encompassing. We're looking at how do you control microorganisms that infect and kill plants, and one of those ways is nutrition. And that's something I've spent pretty much almost my entire career, like 25 years studying silicon and how it affects plant diseases. Current research is it's really going on a lot of different fronts. So we have soil scientists that are still trying to understand what soils. We know soils that are low in limiting, but how do you actually quantify that? So you could actually have a soil test that would tell you this soil is limiting, this is how much you need to apply to correct for that. They're looking at different sources, for an example, and they're looking at different techniques to measure it in the soil. We already have the techniques to measure in the plant. It's pretty tried and true. You can use wet chemistry, you can use X-ray microanalysis, for an example, and they'll tell you if that plant does or does not have silicon in it and what concentration it has. And plants vary in their ability to accumulate silicon, but it ranges anywhere from 1 to 10% on a dry matter basis. So for an example, you look at wetland grasses like rice, they'll accumulate somewhere on average between 5 to 7% on dry matter basis. If you look at dryland grasses like sugarcane or turf, they'll accumulate somewhere between 0.5 to 1.5 on a dry matter basis. And then if you look at dicotyledons, it's about less than 0.2. Sometimes you get a little higher depending. So there's some ranges, and it's just based on the needs of the plant. Recently, let's say in 2006, Ma's group from Japan discovered transporter genes in rice, so it's an active process that moves the element from the soil solution into the roots and then into the plant. And the form that is taken up by the plant is monosilicic acid. So that's silicon surrounded by 4 hydroxyl groups. That's a problem because silicon, as taught by plant nutritionists and soil scientists and plant physiologists for years, is that it's the second most abundant element in the Earth's crust after oxygen. So why would it be important? And back in the mid-1800s, when they were starting to ash plants, even though they found it to be the most abundant element in most plant tissues that was ash, they didn't think it was important or playing a role. But they started to look at that, right? And so it's taken until just recently, with all the research that's been done in the last, I would say in the last 20 years, it's really elevated the recognition, I would say primarily because of the research that's been conducted in controlling plant diseases. And I'm probably biased because I'm a plant pathologist that study plant diseases. Research has revealed that the plant has a whole cascade of defense responses, and silicon seems to prime it. So they think it's a priming effect or maybe a mediated effect because there's a bunch of genes that are either defensive or physiological that are up and down regulated when silicon's applied to the plant. So like in South Florida where I was, they sold silicon as a soil amendment because 25 years ago, it's not recognized as being a fertilizer, okay? And many other companies that would sell it would probably sell it as a soil conditioner or something nutritional supplement. They couldn't make claims about silicon because in the United States, the body that regulates fertilizers is the American Association for Plant Food Control Officials. And they're a group of industry as well as state regulators that define what nutrition is and a lot of other definitions and supply the regulation. And so they had no place to put silicon. The way they define plant nutrition is primary nutrients are NPK, secondary and or micro is everything else. And that's not what we learn in traditional plant nutrition. If you're studying it, in school, we learned that there's macronutrients and micronutrients, and then beneficial nutrients. Okay, and so they did not have a category for silicon. So we went to educate them on silicon, and finally they decided, okay, well, we'll accept this, but we're going to come up with a definition. So what they came up with is beneficial substances, and they define that as any exogenous element that will improve plant growth and function. And so now you can actually sell silicon as a fertilizer in the U.S. And there was one company called Harsco that kind of led that effort. And I think now it's registered in 44 states. Can be sold, I think it's called Crossover. But there's other companies now coming, there's a group called Levy. They have a product called Plant Tough that's being looked at. Calcium Silicate Corporations that I worked with 20 years ago, they have a calcium silicate product they call CalSeal. Well, they invited me to come to talk about it because it's how it's being categorized. Like, from a plant pathology perspective, I would say it's a plant protectant. But some would say, no, it's really a fertilizer because you can get yield influences and it'll change maybe, vitamin or nutritional content of fruit. It's been documented. Or, it's a biostimulant because it affects abiotic stresses and plant growth. Really, it's all three. This is a different audience to sort of introduce them to really, I think, the concept of silicon. I think they may know of it, they may have read about it, but I think this will help sort of wrap their head around it a little better.